Yeah, welcome to Mass City Academy, a city of great learning. We are still in our topic physics under mechanics. We are still in lesson 1, but this time around we are in lesson 1 part 2. In lesson 1, we are treating dimension analysis. So in part 1, I introduced dimension analysis and gave some vital information about it. In lesson 2, we are going to be talking about the advantage, or you call it the significance of dimension analysis. So we go straight to the point. Number 1 advantage of dimension analysis is that 1, dimension analysis are used to check the correction for a physical equation. They are used to check the correction for a physical equation. Let's take one example. They want us to check if this equation is correct. How do I know that this equation is correct? Simple. When I subject it to dimension analysis, homogeneity will tell me if it is correct or wrong. Okay, let's see solution now. What is dimension for velocity is L, t minus 1. This is initial velocity, L, t minus 1. Plus, this is acceleration, L, t minus 2. Times, this is time, capital T. I simplify. I have LT minus 1 here is equals to LT minus 1 here, plus multiply this. I have LT minus 2 plus 1 minus 1. Men and brethren, if we look at this place, you see that we have LT minus 1 here, LT minus 1 here, LT minus 1 here. This is what we call homogeneity. It means that this physical equation is what? Correct. We go to another example. The number 2 example, still under the first advantage. Number 2 example. This question was gotten from a JUPEB examination. This one I'm going to do now. It was asked in JUPEB examination. Okay, the question says, given that D is equals to W L squared over 3 E A K squared, where D is depression, W is weight, L is length, E is Young modulus, A is cross-sectional area, and K is radius of gyration. K is radius of gyration. They now say, ascertain if this equation is correct. We should ascertain if this equation is correct. All we need to do is to subject it to dimension analysis. First of all, I start with my D. D is depression. Its dimension is length. W is weight. Weight and force are the same. So dimension is MLT minus 2. That's dimension for weight. L is length. Its dimension will be L squared. Remember, it is carrying square here all over. There is no dimension for constant. We have already known this. Young modulus. It is over AE. Hope you know. This is strain. There is no dimension for strain. So it is only left, we are only left with force over area. We have MLT minus 2 over L squared. This will take away this, leaving with L raised by minus 1, T raised by minus 2. This becomes dimension for Young modulus. So I bring it here, L minus 1, T minus 2. Then area dimension is L squared. Then radius of gyration dimension is L, but it's carrying square also. Okay. Now we have this is this now. This is this now. This is this. This is this, and this becomes this. So simplifying the numerator, I have M. This is L raised power 4 and T raised power minus 2. Then this becomes M minus 1 plus 2, 1 plus 2, 3, L3, T minus 2. Now at this point, this can cancel out this. This, there is 4 of L up and 3 down, so it will cancel out this, leaving with 1 there. This cancels out this, so I'm having L is equals to L. Finally, if you observe homogeneity, what is here is what is here. It means that this equation is correct. Okay, that is the first example for application for advantage of significant of dimension analysis. We go to number 2. Number 2, advantage or significance of dimension analysis. It says dimensions are used to derive the correct unit of a physical equation. Dimensions are used to derive the correct unit of a physical equation. What are we saying here? It means if I know the dimension of a physical unit, of a physical quantity, I can give you the unit of measurement, provided I know the dimension. Let's take an example. We have a certain physical quantity whose dimension is equals to MLT minus 2. A certain physical quantity has its dimension to be this. They now ask me to find which physical quantity is this and what is its unit of measurement. So my solution becomes, in that this is a dimensioned mass. This is a dimensioned mass. So I can have M. Now this is a dimensioned acceleration. Hope you understand. This is a dimensioned acceleration, LT minus 2. So I have it to be A. Then the unit for M is kilogram. And the unit for A is meter per what? Second. Which physical quantity has this kilogram meter per second is what? Force. I've answered that question. So what we are trying to say here is that if I know the dimension for a given physical quantity, I can give you the unit as well as even name the physical quantity. It says, the gravitational force of attraction between two bodies is given as, gravitational force of attraction between two bodies is given as, the gravitational force of attraction between two bodies is given as this, where G is gravitational constant, okay? R is the distance apart between the two bodies, the two masses, okay? So R is distance, let me keep that. R is distance apart. M is the masses of the body. M is mass of the body. Then F is the force of gravity, gravitational force. So they say the gravitational force of attraction. So F is gravitational force of attraction. Now the question says, obtain the unit of G using dimension analysis. Obtain the unit of G using dimension analysis. So what we want to do here now is this. Obtain the unit of G using dimension analysis. What we want to do here is this now. I want to get the unit of G. Okay, we start. First of all, I'll make G subject of the formula. So I have that G is equals to F R squared over M. That is G. Okay, at this point I have my G to be equals to, what is the dimension for F? Dimension for F is MLT minus 2. Dot. What is dimension for R? Is L, then it's R squared there. What is that? These are masses. What are their dimensions? We have M times M. Okay, G becomes, I simplify what is up. I have M, L raised power 3, T raised power minus 2, all over M squared. I have 2M down, 1M up, so this will take away this, leaving me with L cube m raised power minus 1 t raised power minus 2. Therefore, the dimension for G is L cube m raised power minus 1 t raised power minus 2. But what they asked me to find is the unit. If I know the dimension, I can give the unit. Let me bring it here. Since I now know the dimension, I can give the unit. The unit becomes, this is a dimension, L is for meter. So I have meter cube. This is a dimensioned mass per kilogram. This is a dimension time per second square. This becomes the unit of G. What we have just established here is that this is the dimension for gravitational constant and this is the unit for gravitational constant. I believe that is well understood. Okay. I go to the number 3 for advantage and significance of dimension analysis. Number 3, let's see that. It says dimension analysis is used to obtain relationship between two or more physical quantities. Dimension analysis is used to obtain relationship between two or more physical quantities. Let's see, what do we mean by that? Now, I want to take us a little further. Now, see something. If I have an equation like this, S is equals to half gt squared. This is an equation for a physical quantity. I can also have something like t is equals to 2 pi root of L over g. This is another equation for physical quantity which we use in physics. Now, the question here is now that the person that formed this, that brought this equation, how did he know, or how, if it's a woman, how did she know that g will be multiplying t and that t will be carrying square? The relationship between g and t is multiplication. Now come to this one. The relationship between L and g is division and they are carrying root. Who told him or her about this relationship and this relationship? That is what we say, that dimension analysis is used to check the relationship between two or more physical quantities. So we are going to establish that. Let's see. How do I know the relationship between two or more physical quantities? Is by finding the value for their exponent. Let's take an example here. I'm taking the first example for this. Okay, it says, given the equation of uniformly accelerating motion is given as, given that the equation of uniformly accelerating motion, given that the equation of a uniformly accelerating motion is given as S equals to K Gx Ty, given that the equation of a uniformly accelerating motion is given as this, find the value of x and y if S is equals to displacement, G is acceleration due to gravity, and T is time, Yk is constant. Now, for me to know the relationship between G, K, and T, I need to get the power of their exponent. I'm going to look for the value of x and value of y. Let's work. Solution. Now, S is displacement, which is this dimension is L. There's no dimension for K. So what is this? G is acceleration. Dimension is LT minus 2. Then it is raised to x. This is T, time. Dimension is capital T. Please let this be small t, since it's not dimension yet. Okay, and it's carrying y. Remember, I'm looking for the value of x and y. Okay, I have L equals to Lx t minus 2x times t raised to power y. Let me simplify, especially the right hand side. I have Lx t now. I have minus 2x plus y. So what I'm going to be doing here now is I'm going to find the value of x and y. How do I get that? I will compare the exponent of the right hand side to the exponent of the left hand side for each individual physical quantity. Let's take an example. I have just two physical quantities. I have length, I have time. So let me take for length. Remember the equation was that S is equals to K G raised to power X L raised to power Y. Okay, that's T raised to power Y. Okay, let's continue. I bring this here. So I'm having for L now. L at this left hand side has the power of 1. While L at this right hand side has the power of x. Remember, I'm comparing only their exponent. So therefore, x is equals to 1. I've got the value of x. Now, for t. T at the left hand side, there's no t here, hence the exponent is 0. Then t at this side is minus 2x plus y. Now, remember that I have the value of x already, so I have 0 equals to minus 2 into 1 plus y, which will give me 0 equals to minus 2 plus y. Bring these 2 here, so I'll have that 2 is equals to y. Therefore, y is equals to what? 2. Y is equals to 2. So, I've got these values that x is equals to 1, y is equals to 2. What I'm going to do is now to put them into the equation and see the relationship between t and g. So what I'm going to be having there is now that x is equals to k, which is the constant, which we don't really know here. Then g raised to power x, x is 1. Then t raised to power y, y is what? 2. And this is the equation. That means the relationship between g and t is multiplication, and t is carrying what? 2. That's also that dimensional analysis can be used to find the relationship between two physical quantities. The relationship between two physical. But for advantage number 4. Advantage number 4. Advantage number 4. Number 4 is that dimensions are used to establish the correct formula for a physical equation. Dimensions are used to establish the correct formulas for a physical equation. What are we saying here? Now, a physical equation, if I want to get dimension, if I want to get the formula for a physical equation. Now, let me explain something. When a scientist runs an experiment, for how does he get the formula for that experiment? Example, let's use period of a simple pendulum. The period of a simple pendulum. This experiment is a very common one. Now, if you observe during this experiment, if you want to get the period of this simple pendulum, you are making use of the mass of the bulb. The mass of the bulb is going to be involved. The length of the rope. Length of the rope is involved. You are keeping something constant. You say that full circle gives you one complete oscillation. And full circle is 360 degrees. That means if this bulb moves up half a circle, back half a circle, 180 plus 180, 360. Now, 360 converted to radian is 2 pi. This is kept constant in this experiment. Now, another thing is that before you tilt this bulb, you apply G, as you allow this ball to fall under gravity. So gravity is involved. So what I will do first is to bring out all the parameters that are fully involved in this experiment. So I said, if I want to perform or get the period of a simple pendulum T, what I'm going to consider is I have a constant 1. I have acceleration due to gravity, I have length of the rope, and I have mass of the bulb. These are the parameters that are very important. Now, I will try to get the relationship between M, L, and G. I'll try to get the relationship between M, L, and G. And once I get the relationship between M, L, and G, it will give me the formula for this T. Though I know that my K is what? 2 pi. So let's see for that. So I can now say T is equals to, remember the question said that the application said that dimension analysis are used to establish the correct formula for a physical equation. Okay, now let's take one example under this simple pendulum. Use the method of dimension to show that T is equals to 2 pi root of L over G. This is a question here. Use the method of dimension to show that T is equals to 2 pi root of L over G. This is a formula. Remember I told us that during the experiment, T was equals to, we have a constant, it was there. We have the mass of the bulb. We have acceleration due to gravity. And we have the length of the bulb. We want to find, why is the relationship of all this? How did it become this? What I'm going to do is to give them exponents. I have x, I give this one y, I give this one z. If I can find the value of x, y, z, then I will see if the relationship makes this period of a simple pendulum to look like this. Okay, let's go there. T, what's the dimension for T? Is capital T. Constant has no dimension. Mass, dimension for mass is capital M. Okay, carrying x. This is LT minus 2 carrying y, and this is length L carrying z. Okay, what I'm going to be having here is, I want to simplify this. I have M raised to power x. This y belongs to both of them according to indices. So I have L raised to power y. I have T minus 2 y. Then I have L raised to power z. Okay, at this point I have M. We still have our T here equals to, I have M raised to power x. I have 2L now. L z plus y. Then I have T minus 2y. Okay, at this point, the parameters I have are M, L, and T. Okay, so for T, let's start with T. Take the exponents. At this side, T is 1. While at this side, T is minus 2y. So I'm going to be making y separate of the formula. You can write minus 2y is equals to 1. So that y becomes minus 1 over 2. So y becomes minus 1 over 2. I've gotten the value for y. Let me do for m. For m. At this point, there is no m, so it is 0. At this point, m is carrying x, therefore x is equals to 0. Let me do for, okay, let me put it here. Let's evaluate for that of L now. For L, at this part, L is 0. Whereas at this part, L is z plus y. Remember that we already have the value for y. So I have 0 equals to z plus, what is my y? Half, minus half. Which makes this becomes z minus half. So this can be written as, that is 0 equals to z minus half. Carry this your half, come over to the other side. So I have 0 plus half equals to z. Therefore, z is equals to half. Now, what I have established here that x is equals to 0, y is equals to minus half, and z is equals to what? Half. At this point, I'm going to fill up these powers into this equation to get the relationship between M, G, and L. Okay. So this equation becomes T equals to K M raised to power 0, G raised to power Y is minus half, and L raised to power half. Z is half. This is this, and this is 0. Now, there's something I want us to observe here. Anything raised to power 0 is 1. And if M raised to power 0 becomes 1, that means this will go out. What does it mean? That this equation becomes K G raised to power minus half, L raised to power half. G as M has disappeared. It means here that during this experiment, the mass of the bulb does not really matter. During this experiment, it means if I want to perform a simple harmonic motion or a simple pendulum experiment, in a simple pendulum experiment, the mass of the bulb you want to use does not matter. Meaning that if you like, use a very big bulb, as big as a house, or use a very tiny bulb, as tiny as an ant, it does not affect the period of a simple pendulum. Note that. Okay. Now let's simplify this and see how G and L are related. So note this, that when you are performing experiment for period of a simple pendulum, you have to be careful with the G and you have to be careful with the length of the rope, because both and the constant, they affect the period. But you need not be careful with the mass of the bulb because it doesn't affect the period of a simple pendulum. Okay, this continues. We have T equals to K. This is the same thing as 1 over root of G. We all know this. And this also is the same thing as root of L. This and this are the same, which can continue as K. K times 1 times this will give me K root of L over root of G. This is correct. Now, mathematically, we can write this as K full root of L over G. Mathematically, that can be written. Now, remember that but K equals to 2 pi, which is 360, so that we have T becomes 2 pi root of L over G, and this becomes the equation for period of a simple pendulum, which we have proven. They gave it to us, we have proven it. Now, at this point, I believe you now appreciate dimension analysis and its applications. It is applied so much in physics that you begin to appreciate it. You can use it to check if a given equation is correct. You can use it to check the relationship between 2 or more physical equations. You can use it to find the unit of a given physical quantity. If you know the dimension, you can get the unit. So, at this point, we draw the curtain for advantage or significance of dimension analysis, and also draw the curtain for lesson 1 on dimension analysis.